Hi everyone, welcome back to my YouTube channel. So today we are going to study this theory part of the two-peg test, and also we will solve a numerical on the topic of two-peg test. So this two-peg test is a topic from the chapter leveling. This is actually a permanent adjustment of the levels. It is carried out before we start any leveling work on the field to ensure instrument is in good position or not. So this is the adjustment where various parts of the instrument get distributed from their true positions relative to each other. So this test is carried out to test whether the line of collimation is parallel or not with the axis of the bubble tube when the bubble is in the center of the line. So in this test, we take our auto level and the required instruments are auto level 2 staffs. So this is the procedure of the two-peg test. The first step is to select 2 points, point A and point B, at a distance of L between each other, and these two pegs are set at point A and B. Then the instrument, the auto level, is set at point C at the middle of A and B, and the staff reading is taken from this point C. Staff reading at station A, that will be X, and staff reading at B, that will be Y. So the true difference will be X minus Y. And then shift the instrument at distance D. You can shift the instrument at A also, or at this point also near B. Now setting the instrument at distance at point D from A, at a small L meter. So now we will take the staff reading from this point D. At A, that will be X1. For B, that will be the staff reading will be Y1. So the apparent difference here will be X1 minus Y1. If the two differences, the true difference and the apparent difference are equal, the instrument is an adjustment. And if not, find whether there is a rise or fall from A to B. If X is greater than Y, then there we will use negative sign rise from A to B so that B is higher. So the negative sign is used because the staff reading decreases with the height, and vice versa for the fall. Then we will calculate the reading on peg B, reading on A, plus minus true difference, whereas reading on peg B is Y2, since Y1 is the absorbed staff reading at B, and Y2 is the true difference the staff reading. If Y1 is greater than Y2, then the line of collimation is inclined upward, and if Y1 is less than Y2, then the line of collimation is inclined downward. Then we will calculate the net collimation error in distance L. So collimation error in distance L is Y1 minus Y2, whereas the collimation per unit distance will be Y1 minus Y2 by L. Now we will calculate the correction for reading A and B. The collimation error on peg A will be the expanded distance, that is L, by the distance between the two staff into Y1 minus Y2, and the collimation error on peg B will be the expanded distance plus the distance between the two staff divided by the distance between the two staff into Y1 minus Y2. So we are setting up the instrument near B. Then while calculating the collimation, while correcting the collimation on peg A will be L plus this distance, L plus this capital L divided by whole L. Here is a numerical of two-peg test. The given question is here. A leveling instrument was set up exactly midway between two pegs. So the L is 50 meter here, apart at A and B. These are the 2 point A and B where the staff readings are taken. The staff reading were 1.875 meter and 1.790 meter respectively at A and B. So this will be X at A and Y at B. Now the level was shifted to a 0.5 meter from B on the line AB produced, and the staff reading were these. These are X1 and Y1. So determine the current staff reading when the line of collimation is exactly horizontal during the second setup. So when the line of collimation is exactly horizontal during the second setup. Here solution given L is equal to the distance between two staff reading at first A and B is 50 meter. So at first this is point C, and these are the two staff readings. This is A and this is B. These are the staff readings here. This is X and this is Y. Two peak test 50 meter apart. The staff reading are X is equal to 1.875 meter and Y is equal to 1.790 meter. Now, the level was shifted to 0.5 meter from B on the line AB produced. So this is shifted to B. This is A, this is B, sorry, this is shifted to B. So this is C and this is point D. This is 5 meter now. This will be X1 and this is Y1. This is total distance 50 meter. So here at the second condition we have X1 is equal to 1.630 meter, Y1 is equal to 1.560 meter and L is here 5 meter. So here we have true difference is equal to X minus Y, which is equal to 1.875 minus 1.790, that is 0.085 meter, and the apparent difference is equal to X1 minus Y1, that is 1.63 minus 1.56, which is equal to 0.07 meter. Here since apparent difference and true difference are not equal, so line of collimation is not adjusted. So this has most gone inclined here since B is higher here. Since this B is at higher, so this must be up to here. Now true staff reading at A, Y2 is equal to Y1 plus minus true difference, which is equal to, we have Y1 is equal to 1.560 plus true difference, that is 0.085. True difference will be added here to get the true staff reading at A. So now error is equal to 1.560 plus 0.085. This is 1.645 meter. Now error is equal to, here the true staff reading at A, X2. True staff reading at A is X2 here. So error will be observed minus the calculated here. The observed reading is 1.x1 minus x2, which is equal to 1.630 minus 1.645 meter, which will be equal to 1.630 minus 1.645 meter. Here it is in negative, so the correction will be positive here. Error. Now correction, since the error is negative, so the correction will be positive. Now correction at A will be equal to, correction at this A will be equal to this distance plus this extended distance, that is 5 meter, L plus L by L into error, that is 0.015, which is equal to L plus L is 55, 55 by 50 into 0.015, which is equal to 55 by 50 into 0.015, that is 0.0165 meter. Now correction at B is equal to this distance L by L into 0.015, which is equal to 5 by 50 into 0.015, which will be equal to 5 into 0.015 divided by 50, that is 0.0015 meter. Now the current staff reading on A will be equal to this x1 plus correction at A, that will be 1.630 plus 0.0165, which is equal to 1.630 plus 0.0165, that is 1.6465 meter. And current staff reading on B will be equal to y1, that is 1.560 plus correction at B, that is 0.0015, which will be equal to 1.56 plus 0.0015, that is 1.5615 meter. So this is all for today's video. For such more numerical we will solve in another video. Thank you so much for watching. Please like and subscribe my channel.